Okay, question 12. In this question, p is a real constant. The equation sin x cos squared x equals to p squared sin x has n distinct solutions in the range 0 to 2 pi. Which of the following statements is or are true? Okay, so when we're interested in the number of solutions in the thing, what do? Well, we try to simplify the equation and then try to factorize it, right? So remember, it's very tempting to cancel sin x both sides, but never do that. All right, never cancel expressions on both sides. So sin x cos squared x minus p squared sin x equals to 0. Yeah, that's the proper way of doing it. And then you can factorize, right? So sin x brackets cos squared x minus p squared, and then you can factorize further sin x cos x plus p cos x minus p equals to 0. So far so good. Okay, so basically, no matter what the value of p is for now, I'm guaranteed at least 3 solutions already, right? Because when sin x equals to 0, I have 0, pi, and 2 pi as my solutions already. All right. So, I mean, statement 1, then it will be clearly false, right? Because it says n equals to 3 is sufficient for p to be greater than 1. But what can I do? Right, I can pick p to be something dodgy, such that p is not greater than 1. For example, what can I pick? I can pick p is bang on 1. Right? What if I pick p is bang on 1? Have a think. So then cos x equals to -1. And how about here? This one will be cos x equals to 1. Right? And these solutions, they literally overlap with these. Right? It overlaps with sin x equals to 0. Yeah? So n equals 3 is insufficient for p to be greater than 1 because I can pick p equals to 1 and n can still be 3. Okay, cool. Now, how about statement 2 then? N equals to 7 only if p is between -1 and 1. What do I do? Okay, so if I need n equals to 7, then ideally, we know that the sin x factor generates 3 solutions already. So we want each of the 2 brackets behind to generate 2 solutions each, right? Okay, so if you wanted to generate 2 solutions each, you've got to make sure that the p is within range of the cos function, right? It's within the range of the cos function. So what's the range of the cos function? The cos function is within range of -1 and 1, right? But then, technically, when it hits -1 or 1, when it hits both ends, we said just now that it overlaps with the solutions of sin x, which makes n equal to 3 only. All right, so we're going to get rid of the equal signs here, because that produces n equals to 3, but now I want n equals to 7. All right, so because the range is 0 to 2 pi today, so it's guaranteed that any value of cos x will give me 2 solutions. All right, so I'll have 3 solutions at the start, 2 solutions, and 2 solutions again, which gives me n equals to 7. Yeah. And that's the only possible situation, right? Because if you choose p to be somewhere outside of that range, then your cos x won't hit it. You have 0 solutions for the 2 laughter brackets. Yeah, so that's why the only if is perfect here. So statement 2 is very correct. So I'll have option C, 2 only.